Example 4 is very similar to examples that we have done in our previous chapter, except now we're going to actually graph it along with solving it. So it's talking about an object falling from the height of a building with the equation f of x equals negative 16, or f of t equals negative 16t squared plus s sub 0. S sub 0 is our c value in this case, and it's our starting height. So this is just like the vertical motion model. We don't have an initial vertical velocity because an object is dropped, not thrown. So it says we're starting a height, an egg is dropped from a height of 64 feet. So we're going to start with the equation f of t equals negative 16t squared plus 64. Before we try to graph it, we're actually going to solve it by factoring, what we've done in the last chapter. We want to know how many seconds does it take for the egg to hit the ground. So we're finding the x-intercept. Another word for that is the 0, the solution, the value when x is 0. When y is 0, I'm sorry. So therefore, we're going to replace f of t with 0 because we're finding the value of t, or the x-intercept when y is 0. So 0 equals negative 16t squared plus 64. The very first thing we're going to do is factor out the GCF. And in this case, it's negative 16. So 0 equals negative 16 times the quantity t squared minus 4. From our last chapter, you should recognize the difference of two perfect squares. And we're going to factor it as such. So negative 16 times the quantity of t minus 2 times the quantity of t plus 2. And we're going to solve each factor. When we set each factor equal to 0, we get our solutions of t equals negative 2 and positive 2. We know we can't have negative time, so therefore it's going to take 2 seconds for our egg to hit the ground. And now we're going to graph that situation. So we have our graph here. It's only in quadrant 1 because we're only dealing with positive values. On our x-axis, we have time, and that would be in seconds. And on our y-axis, we have height, and that would be in feet. Okay. We're talking about 2 seconds, so we can count if you want to count by 0.5. Okay. And we're starting at 64 feet, so why don't we count by eighths? Okay. And we only really have to graph our starting height at 0 seconds and our ending height, which is 0 after 2 seconds. And in real life, we really only have, because this is a real life parabola, we really only have half of the parabola because we can't have negative height or negative distance. And when we look at our domain, our possible x values are from 0 to 2. So we would write that x is greater than or equal to 0 and less than or equal to 2. And our range, when we talk about our possible y values, our range is greater than or equal to 0 and less than or equal to 64. Okay.